Whenever this condition is possible, there exists a point where the derivative of the function at the point C will become 0. The derivative of the function at the C must be given as f of b minus f of a divided by b minus a. This is the statement of the Rolle's theorem. The tangent at the point C will be always parallel to the secant joining the points in the interval a comma f of a and b comma f of b. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we will be studying about the Rolle's theorem as well as mean value theorem. So, what is the link in differentiability between the Rolle's theorem and mean value theorem? Actually, Rolle's theorem and mean value theorems gives a function and its derivative at a particular point through a graphical as well as the theoretical method. So, let us see what is the statement of Rolle's theorem. Rolle's theorem says that f is a function from a domain to a real number, which is a range, is continuous on the closed interval a comma b and differentiable on a comma b such that f of a is equal to f of b. Then there exists a point C in the open interval a comma b such that f dash of c is equal to 0. So, here the conditions are f must be a continuous function as well as differentiable function such that the value of the function at a as well as b must be same. Whenever this condition is possible, there exists a point where the derivative of the function at the point C will become 0. So, when we see it through graphically, we can see here. So, this is a point, or this can be taken as an interval from a to b here. So, from a to b the function is clearly continuous. You can see this is a graph of a continuous function and it is differentiable at every point inside the domain. Remember, every differentiable function is continuous. So, therefore, whenever it is defined inside the interval a comma b, since it is also continuous and it is differentiable at the interval. So, here is the point, clearly you can see this is the point where f of a is equal to f of b. Now, if this is possible, there exists one point C where the derivative of this function will be completely 0. So, this is actually the f dash of c. So, at this point the derivative of the function is 0 and the slope of the curve or the tangent here is exactly 0 and the tangent is parallel to the x-axis. So, for each particular point we have a tangent here, you can see, which becomes a tangent, and at particular point the tangent will become parallel to x-axis where its derivative is 0. Thus, what does the Rolle theorem says here? So, Rolle theorem states that the slope of the tangent at any point on the graph y is equal to f of x. Here I have taken an example of two simple graphs here. So, this is nothing but the derivative of f of x at that particular point. So, the slope of the tangent at any point on the curve y is equal to f of x always denote the derivative of the function at that point. So, here we can see the tangent which is parallel to x-axis. So, here is actually the point existing where f dash c becomes 0. So, here we can clearly say if you draw a tangent at a particular point and that point represents the derivative of a point which also equal to the slope of a tangent. So, thus we can say dy by dx is nothing but the slope of tangent. So, this is what the Rolle's theorem states. The slope of the tangent at any point on the curve indicates the derivative of the function at that particular point. Next is the mean value theorem. The mean value theorem is just an extension of Rolle theorem. So here also we take f as a function from closed interval a comma b to r, which is a continuous function on the closed interval and differentiable on the open interval. Then there exists a point c in open interval a comma b such that f dash of c, that is the derivative of the function at the c, must be given as f of b minus f of a divided by b minus a. This is the statement of the Rolle's theorem. Let me explain it through a graph here. So what does actually the mean value theorem says here is, the mean value theorem states that at a point c in a comma b, in the interval a comma b, clearly you can see this is a comma b interval and this is the point c. So at that point c, when you draw a tangent, so indicating point C, that is always parallel to the secant which joins the point A f of A and B f of B. So I have already told you, so this indicates f of A and clearly this point indicates f of B. And this point can be denoted in the form of A comma f of A and this as B comma f of B. And when you draw a line, you will get a secant to the curve. So what does mean value theorem says that here is, the tangent at the point C will be always parallel to the secant joining the points in the interval a comma f of A and b comma f of B. And we know that here also the point represents the derivative of a function. So the tangent, when it is a tangent to the curve, the slope of the tangent always here also denotes the derivative of the function at the given point. Thus it is given as f dash of c. And here f dash of c denotes the slope of the tangent. And here in the mean value theorem, it is given by f of b minus f of a divided by b minus a. When this satisfies with the given function, then we say the mean value theorem is satisfied. So thus Rolle's theorem and mean value theorem helps us to understand the derivative of a function at the particular point. So now here, verify Rolle's theorem for the function y is equal to x square plus 2, a is equal to minus 2 and b is equal to 2. So the point a comma b, so the domain where a and b are given here. So clearly the function is given y is equal to x square plus 2. We know that x square plus 2 is a polynomial function and we know that every polynomial function is continuous. That is why we can clearly say that here, so y is equal to x square plus 2 is continuous in the interval minus 2 comma 2. So continuous is always for the open interval, that is why it's clearly continuous, and is differentiable and is differentiable. It can be differentiable. So in the interval minus 2 comma 2. So according to Rolle's theorem, if the function is continuous in the closed interval and differentiable in the open interval, then we have to check what is f of minus 2 as well as f of 2. And it has to be equal. Let's see what is f of minus 2. F of minus 2 is minus 2 whole square plus 2, which becomes 6. And f of 2 is 2 square plus 2, which is equal to 6. So this implies f of minus 2 is equal to f of 2. So then according to Rolle's theorem, so from Rolle's theorem, if these conditions are possible, that is, if the function is continuous, differentiable and f of a is equal to f of b, then from Rolle's theorem, there exist C belongs to a comma b such that f dash of c is equal to 0. Now we have f dash of c is equal to 0. So let's see here what is f dash of x. So f dash of x. So here y is nothing but f of x. So f of x is equal to x square plus 2 means what is the derivative? F dash of x will become 2x. So now f dash of c is equal to 0 means we can equate 2x or which can be written in the form of 2c is equal to 0. This implies c is equal to 0. So clearly c belongs to minus 2 comma 2. So therefore c belongs to the interval minus 2 comma 2. So thus Rolle's theorem is satisfied here. So this is 3-mark question which can be asked in your examination. So there may be a question on Rolle's theorem or mean value theorem for 3 marks in your examination. So these types of questions comes into the category of 3 marks from the chapter differentiation. So what you have to verify here to verify Rolle's theorem or mean value theorem, first you have to check whether the function is continuous and differentiable at the given point. Then you have to satisfy the condition of Rolle's theorem. Whenever the point exists, just find out its derivative and equate it to 0 and verify whether the point belongs within the interval. Then the Rolle's theorem is satisfied. Next question. Verify Rolle's theorem for the function f of x is equal to x square plus 2x minus 8. X belongs to the interval minus 4 comma 2. So clearly it's a polynomial function. Hence we can say f of x is continuous in the interval minus 4 comma 2 and differentiable in the interval minus 4 comma 2. Now here we have the interval a comma b. We have to verify whether f of a is equal to f of b. Let's check f of minus 4. So f of minus 4, when you take here minus 4 whole square plus 2 into minus 4 and here minus 8. So minus 4 whole square is 16. 16 minus 8 is plus 8. 8 minus 8 is 0. Next we will check it for f of 2. So f of 2, 2 square plus 2 into 2 minus 8. So 2 square is 4. 2 2s are 4. 4 plus 4 8. 8 minus 8 0. So clearly f of minus 4 is equal to f of 2. Now the third condition is also satisfied. So then there exist. So this is the symbol for there exist we use. There exist c belongs to the interval minus 4 comma 2 such that f dash of c is equal to 0. So let's find out what is f dash of x. F dash of x means derivative of the given function. X square is 2x. Derivative of 2x is 2 and derivative of minus 8 is 0 because it's a constant. Now this can be implied in the form of 2c plus 2 is equal to 0. So this implies 2c is equal to minus 2 or c is equal to minus 1. So this is the point here. So whether it lies in the interval? Yes. So therefore c belongs to the interval minus 4 comma 2 and hence the Rolle's theorem is satisfied. Next question. Verify mean value theorem for the function f of x is equal to x square in the interval 2 comma 4. So here we have to verify the mean value theorem. So again, to verify the mean value theorem, the function must be continuous, the function must be differentiable and f dash of c must be equal to f of b minus f of a divided by b minus a. So let's see here. Clearly f of x is x square. It's a polynomial function. So therefore f of x is continuous in the interval 2 comma 4 and differentiable in the interval 2 comma 4. So for continuous you have to write closed interval. For differentiable you have to write an open interval. Now it is satisfied. So now let's check the functional value of 2 and 4 here. So let's find f of 2. So f of 2 is 2 square which is 4 and f of 4 is 4 square which is 16. So thus f dash of c is equal to f of b minus f of a divided by b minus a. So f of b is f of 4. So which is 16 minus 4 divided by b is 4, a is 2, so 4 minus 2. So 16 minus 4 is 12 by 2, which is equal to 6. Now here f dash of c is equal to 6. So but now let's find out f dash of x. So f dash of x is equal to 2x. So this implies, so instead of 2x, f dash of c can be written as 2c is equal to 6. So this implies here c is equal to 3. So we got c is equal to 3. So clearly c belongs to the interval 2, 4. So whenever this is satisfied, we can say here there exists the point C which belongs to the interval given. So hence here the mean value theorem is satisfied. Next question. Verify mean value theorem if f of x is equal to x square minus 4x minus 3 in the interval a comma b where a is equal to 1 and b is equal to 4. Again it's a polynomial function. So therefore f of x is continuous in the interval, so 1 comma 4, and so it's a closed interval, and differentiable in the closed interval 1 comma 4. Now let's find out f of 1 and f of 4. So f of 1 is 1 square minus 4 minus 3. So here 1 minus 4 is minus 3 minus 3 minus 3 minus 6. Next f of 4, so 4 square minus 4 4s are 16 again minus 3. So 16 minus 16 0, 0 minus 3 is minus 3. So now let's verify f of b minus f of a divided by b minus a. So let's check this. F of b minus f of a is, so f of b is minus 3, f of a is, so minus of minus 6 whole divided by 4 minus 1. So here it becomes 3 divided by 3 which is equal to 1. So therefore mean value theorem states that there exists C belongs to the interval 1 comma 4 such that f dash of C is equal to 1. So this is what actually f dash of C here. Now since mean value theorem says that there exists a point C belongs to 1 comma 4, let's find out the derivative of f of x. So the derivative of f of x is f dash of x is equal to 2x minus 4 minus 3 becomes 0. So therefore in the place of f dash of x just replace f dash of C is equal to 2c minus 4. So we have got f dash of C is equal to 1. So therefore here 1 is equal to 2c minus 4, or we get 2c is equal to 5. So this implies C is equal to 5 by 2. So clearly 5 by 2 is nothing but 2.5. Thus this belongs to the interval 1 comma 4 and hence the mean value theorem is satisfied. Next question. Verify mean value theorem if f of x is equal to x cube minus 5x square minus 3x in the interval a comma b where a is equal to 1 and b is equal to 3. Find all C belongs to interval 1 comma 3 for which f dash of C is equal to 0. So until here you have to verify mean value theorem. So here in the second case f dash of C becomes 0 means it is nothing but the Rolle's theorem. You have to find the point where f dash C becomes 0. Now first let us verify mean value theorem. So clearly it's a polynomial function. So therefore f of x is continuous. It is continuous in the interval 1 comma 3 and differentiable in closed interval 1 comma 3. So now let us find out f of b and f of a, that is f of 1 and f of 3. So f of 1 is 1 cube minus 5 into 1 square is 5 minus 3 into x is 3. So here 1 minus 5 minus 4 minus 4 minus 3 minus 7. Next f of 3, 3 cube minus 5 into 3 square, that is 9 5s are 45 minus 3 3s are 9. So here we will get minus 27. Now let's find out f dash of c, that is f of b minus f of a divided by b minus a. Or instead of b minus a, you can directly write the values here. That is, you can write f of 3 minus f of 1 divided by 3 minus 1. So here it is minus 27, minus of minus 7 becomes plus 7 divided by 3 minus 1 is 2. So here it is minus 20 divided by 2, which becomes minus 10. So now therefore, mean value theorem states that there exists a point C which belongs to the interval 1, 3 such that f dash of C is equal to minus 10. Now we have to find the derivative. Let's find out f dash of x. So f dash of x becomes x cube is 3x square, 5 is a constant, x square is 2x, minus 3 is a constant, derivative of x is 1. So here it becomes f dash of x is equal to 3x square minus 5 2s are 10x minus 3. Thus the derivative at point C becomes f dash of C is equal to 3c square minus 10c minus 3. So here it is. So we get just replacing c here, 3c square minus 10c minus 3. Now f dash c is given as minus 10. So 3c square minus 10c minus 3. So then you get 3c square minus 10c. So when you shift that, it becomes plus 7 is equal to 0. So here I can write it as 3c square minus 3c minus 7c plus 7 is equal to 0. So 3c common, c minus 1, and here minus 7 common, c minus 1 is equal to 0. So this implies c minus 1 and 3c minus 7 is equal to 0. So therefore c is equal to 1 or c is equal to 7 by 3. So here our interval condition is C must belong to open interval 1, 3. But here this is not possible. Since this is an open interval, we have to exclude 1. We have to take the points after 1. So therefore, only C which is equal to 7 by 3 belongs to the interval 1, 3. So thus the value here is approximately will be equal to 2.33 something. Hence the only point here satisfying the condition is 7 by 3 belongs to 1, 3. So therefore, the only point is C is equal to 7 by 3 which belongs to the interval 1, 3 satisfies f dash of C is equal to 0. So here we get 2 points where C does not belongs to the interval and the only point is 7 by 3. Thus, if you take f dash of C is equal to 0 and when you substitute, what is f dash of C? It is 3c square minus 10c minus 3 which is equal to 0. And when you put the value of C as 7 by 3 in this equation, you will get the f dash C as 0. So this is the only point which is satisfying the mean value theorem and also satisfying f dash of C is equal to 0. So thus you can see these type of questions from Rolle's theorem as well as mean value theorem. So these type of question carries 3 marks in your examination. So this is all about the chapter continuity and differentiability. So this is a very important chapter of containing most maximum number of questions and overall you have 20 marks from this chapter. We'll meet you in the next session with the new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.